So yesterday we were discussing about the materialized views. So it was giving error, right? So let's open that file, or we can start from here freshly. Let's select our database, the training. So we are looking at the table called orders. Okay. So here in this table, I want to know how many orders each customer has placed or how much amount each customer has spent on purchasing the products. Okay, so for that we can write select customer ID, comma, count of star as number of orders, comma, sum of price into quantity, because for some orders there are multiple quantities, so this is the price of each unit, so we have to multiply that price into quantity as total amount. So from orders group by customer ID. So first let's see if this is working. Incorrect syntax near orders. Why? Sorry, group by. From price into quantity as total amount from orders. What's the mistake here? Incorrect syntax near orders. ORDRS. Sum of price into quantity. Let's see this once again.
You have given
Sorry,
underscore and line 4
line 4.
underscore.
Okay, thank you.
No issues.
Okay, so this is working now. Now we have to create a materialized view on top of this. Okay, so for creating a materialized view, we should first create a schema binding. Schema binding means we should define the schema to that materialized view first. So let's create it. So generally in the real time, we might not be using the Microsoft SQL Server. Very rarely we come across this. Maybe these were our legacy systems or the source systems, but most of the times it would be Snowflake. So in Snowflake, creating a materialized view is quite simple. Like create, we just have to specify the word materialized. So in this server, it is little different. So let's see. So create view. Here we should definitely provide the schema name. While creating the materialized views, we should definitely provide the schema name, which is our DVO. Let's say order summary. My view name is order summary with schema binding as. Now let's copy this query. Okay, so it will give an error now. Okay, let's see. Let's try to create it. Okay, cannot schema bind view DVO order summary because name orders is invalid for schema binding. Name must be okay. Here it is telling don't directly use this. I told you, right? This DBO name is mandatory. I mean, the schema name is mandatory. Okay, so let's run this and see again. It might give error again. Hmm. It has completed successfully now. So first let's look at data from here. We still have to do few things on top of this. Let's look at the data on this. Okay, it is giving data, but uh, we have to define indexing on this. Okay, so because whenever the data changes in these tables, orders table, then it has to refresh that. So what we have discussed about the materialized views, it will store the data on the disk, and periodic refresh should happen for that. So for that we should define some kind of indexing, or it makes the materialized view an indexed view. Okay, even though you define that index or not a problem, but let's create an index on that. Create uh, what kind of index I can create on this. On the customer ID, I'll create it. Create unique clustered index. This is one of the type of index. The name of this is index view order summary on this view on the column customer ID. Let's run it. Because it uses the aggregate count, use big count instead. So here the problem is, if you see here, we are doing a count. So while creating the materialized views, we are supposed to use count big instead of count. So that is like a syntactical thing, count big. Okay, let's run this one more time. Let's make this as 1. Get created. Here also on 1, I'm going to create it. What happened? Cannot create the clustered index on because the view references an unknown column. Okay, we should provide some alias name to this. We have already provided some aggregate of nullable expression. Consider referencing only non-null values in some is null may be useful for this. So this is causing error because we are trying to create a unique clustered index. Okay, so while it is trying to create a unique clustered index, but while doing the sum, it is not expecting the nulls. It is expecting only not nulls, but we did not apply any constraint on this, right? We did not apply any constraint on this, so there might be a possibility it will lead to zeros or null values here. So that is the error it is giving. Consider referencing only non-nullable columns in the sum. Okay, let's do built-in function. Sorry, what is this? Built-in function sum returns int. Yes. Let's make it is null. So what is null will do is, if this value is null, if the price value is null, it should replace with something. So I will replace that with 0. Similarly, if quantity is also 0, I'll replace that with, sorry, if the quantity is also null, I'll replace that with 0, so that the sum will always be having some value. Let's make this 2. Okay, let's create a index Okay, now it is created successfully. So for the materialized views, there are some considerations. Uh, like we should, instead of count, we should use big count big, and we should not do select star. Select star is not allowed. So let's write it down. What are all not allowed? With the schema binding, this is mandatory. Schema binding is mandatory. Then use table name along with schema. Okay, dbo dot orders. Otherwise, it doesn't work. So don't use select star. Select star is not allowed. Don't use select star. I think somebody is talking. Please be on mute. Or if you have any questions, let me know. So don't use select star. Also, we are restricted not to use distinct top outer join, which means full outer join. These are restricted to allow in the materialized view, but there is no restriction in case of the standard view and union. These are not allowed to use in the materialized views. Use count big instead of just the normal count. All referenced objects must be in same database, which means, I mean, whatever we are referencing here, all of that should be in the same database. It should not be like one is in the DE training, another is in the master database. That is not allowed. Okay. We should create unique clustered index. Okay. So this leads to faster query performance because we are storing the results on the disk. These are the pre-compiled or pre-calculated results. So these will be stored in the disk. Generally, these are used for some reports because we are doing aggregations here. Number of orders, total amount. These are like some of the metrics important for business. So it helps in faster retrieval of the data and also easy building of the reports. Okay, so this is all about the materialized view. This much is enough for the materialized view. Okay, so now let's switch into another topic, window functions. Okay, window functions. Let's see. First of all, what window functions are. Generally, whenever you are doing some aggregations, let's see here. If you are doing some aggregations, you should definitely do that in the group by. So, without doing a group by, I still want to calculate some kind of aggregations, or I want to generate numbers based on some order, or for each department I want to know first highest, second highest, third highest. I just want to generate the numbers based on the salary for each department. All those kind of things will be possible using the window functions. Okay, so there are four or five window functions. Let's write it down. So window functions are, first you will see the examples, later you will get to know the functionality or you will understand it easily. So there are four or five window functions. Let's see, row number, rank, dense rank, lead, lag. So these are the main window functions. We can still have more, I'll tell you. Okay, so this row number, rank or dense rank, these three are used to generate numbers based on the order and partition. We will see what is order, what is partition and all. We'll see the lead and lag later. Okay. So let us take our employee table. Select star from employee. Okay. So what we have here is department ID, salary, name, and employee ID. So what I want to do is, I from this complete table, I want to know the first highest, second highest, third highest, and so on. Okay. So I just want to have another column which will give the ranking here. So salary, whoever is having the greatest, maybe this person is having highest, he should be given the number one. So after 55, this person is also having number one, but you have to decide either you want to give number one to both of them, or you want to give number one to one and two to another. How do you want to do? You have to decide that. So we'll see how we can do that. So let us say I want to generate a sequence. Okay, that sequence can be generated using any of these functions. Okay, sequence can be generated using any of these functions. So let's say select. I want all the columns along with the sequence. First, let's use the row number. Row number over partition by. Sorry, partition by is not required right away. I'll tell you the partition by later. So over order by the salary column. Over order by salary in the descending. Okay. I want to give ranking based on the descending order, as we should provide some alias name to this column because this is a derived column. We should provide some alias row number from which table employee. So let's see. Okay. It has generated the sequence. If you see here, this ID 106 and 109, both of them are having the same salary, but it has given two different numbers. Okay. So every time this might not be fixed because first, I mean, we are using a row number. These are having the two same values. These two are having the same values. I'm just doing a order by on the salary column. So we don't know which will come first. Either 109 might come first or 106 might come first. Every time we cannot guarantee that only this person will be getting the number one. That is, there is no guarantee for that. Okay. In order to have some, in order to have that kind of thing, you should also use another order by clause, another column in the order by clause. Let's say employee ID. Employee ID in the ascending order. Let's see. I think this is not allowed. Okay, it's allowing. Okay, now this will guarantee us. So first it will sort by the salary column in the descending order and later employee ID in the ascending order. Okay. So let's say employee ID also I'll make it in the descending. See 106 is given the number one rank. Now I'm making the employee ID descending order. See here, now this employee 109 is given the row number 1. So it depends on you which person you want to give the row number, which person you want to give the first rank. So in the first place, sorry, in the first place we have written without using order by on the employee ID. I'll be keeping it for your reference. Okay, so it is generating the row number. That's fine. You can control which row you want to have the number one and which row you want to have the number two. That you can control. So now I'll use the rank. If you see here, irrespective of whether they are having the same rank or a different rank, it is generating the sequence based on the order we have defined here. Okay, that's what we have written. Used to generate numbers based on the order. Okay, we did not come to the partition yet. We'll come to that slowly. Okay, so let's do partition by now. Okay, now what I want to do is for each department. Okay, for each department, I want to generate the sequence. For ID number 1000, 1, 2, 3. For another department, 1, 2, 3, and so on. Okay, over. For in order to generate that kind of ranking, we should use, let's remove this employee ID over partition by. So what we want to do partition by for each department, that each will come here for partition by the department ID, order by the salary for each department, do a ordering on the salary in the descending, and then provide a row number to that. Okay, let's see. See here, this is department 1000. Okay, so these are having four different salaries and it has given four numbers. Similarly, for this department, we have three employees with both two of them having the same, but still we were given number one and two. In this case, again, we don't know who will be given number one or who will be given number two, right? So in order to control that, you have to use the employee ID. That's up to you how you want to manage. And coming to this, we have two and another two for this department ID. Okay, right. Let's see how we can generate. This is giving a sequence. Even if we have repetitions, if these are same, it is giving two numbers. But I don't want that to happen. I want both of them should be given the same rank. Okay, I want both of them to be given the same rank. So for that, we need to use another window function, rank. So the syntax is same, just you need to change the keyword here, rank. I'm just doing order by salary on over the complete table. Okay, now let's see. These two persons, ID 106 and 109, they are given the same ranking. Okay, and any other are having the same. These two. See here, these two people are having the same salary, so they were given the rank 3. What happened to the rank number 2? It was skipped because whenever the rank, sorry, whenever the number 1 is given to two people, it will skip the next number. Okay, this will be treated like 1 and this will be 2. So immediately it would be 3 and this would be 4 and this is 5 and again 6 is missing. 7 is there. This will be treated like 8. We have 9 here and 10 and 11. So in case of rank, if there are multiple rows with the same rank, the next number will be missing. Let's say if we have three rows for the rank number 1. So the next number will be immediately 4. Okay, the next number will be immediately 4. Let's try to make an insert into this table. Insert into employee values. So let's see what values I can provide. Okay, 110 is also there. 111. Employee ID is 111. Let's see. Employee ID name. Let's make salary the same as that of the rank 1. 55 belongs to the same department. 1001. Okay, let's insert it. Okay, now we'll run this query again. Okay, see here. Now we are getting row number 1 or the rank 1 three times because three persons are having the same salary. So the immediate number is 4. It is like 1 is this one, 2 and 3, and immediately it is 4. How many other numbers it is repeating, those many numbers will be skipped in between, okay, in the sequence. Okay, now let's do the same thing using a partition. Partition by the department. Partition by department ID. Okay, sorry, comma is not required here. Okay, so for now, see here 55,000 where it is. Okay, it is here. They all belongs to the same department. So all of them are given the same rank, and the next person is given the rank 4. Okay, so here these are different. So different numbers were given, and department this one also having a different salaries, and these are also different. So different numbers are generated. So that's the usage of the rank. Now let's see the dense rank. Dense rank. Okay, I'm doing just order by on the salary throughout the table. So let's see. See here now in the dense rank also, uh, the persons having the same salary, they were given the same rank. See the first three rows, they belong to same salary. They were given the same rank 111. And the immediate person, immediate salary, it was given 2. So that's the basic difference between a rank and the dense rank. Okay. In the rank, the sequence numbers will be missing if there are any repetitions. In case of dense rank, even though there are repetitions, same number will be given to the same value, and the next number will not be missing. Okay. So that's about the dense rank. See here, everywhere it is 3 and immediately it is 4. And then 5. Even though we have repetitions, no numbers are missing. Numbers are not missing here. So the same will apply along with the partition clause over partition by department ID. Let's see, now it will give ranking for each department. Okay, so within the department, there are no repetitions here. And in the second department, we have the repetitions. So all of them were given the number 1 and we are given the number 2 here. And so on. Okay, let's try to put all the things together. Row number, rank and dense rank so that you will observe the difference. Okay, so take this with without partition and with the partition, we'll see both of them. Let's paste it. Sorry, let's copy this line. Okay, let's make this row number, rank and the dense rank. Let's rename it row number, rank, dense rank. Okay, let's run this from employees table. I'm just ordering. Oh, sorry, I did a partition. Well, let's remove the partition for now, or we will write that later. Let's remove partition by. Oh, let's see. Okay, observe here carefully. The first is generated by row number. This is by rank, and this is by the dense rank. We are just doing a order by on the salary. See here, all the first three rows are having the same salary. In case of rank, it is giving numbers 1, 2, 3. In case of row number, it is giving 1, 2, 3. Irrespective of same or different, it doesn't bother. It will just give the sequence. In case of rank, it is giving the same number. In the dense rank also, it is giving the same number. If you look at the next number, it is 4. row number, it is giving sequence irrespective of repetitions or non-repetitions. It is giving the sequence. In case of rank, the consequent numbers are missing. Okay, the immediate numbers are missing. How many ever rows we have it here, those many number of rows will, those many numbers will be skipped in between. Okay. In case of dense rank, even though we have repetitions, no numbers are skipped. Okay. So here these two 50,000 are same. So here it is 4 and here it is 2. And again these two salaries are same. So in case of rank and dense rank, they were given the same salary, but the sequence matters. Okay. Depending on how you want to generate, you can use the corresponding window function. Okay. Let's say with the partition by clause. Okay, now for each department, 1000, it has given the sequence because in the first place there were no repetitions, it's all same. In the second department, these are all same, but still we were given different row numbers, same rank and same dense rank. The next number is skipping, and here the next number is not skipping. And the same applies here also. These are different, so different numbers are generated. These are also different numbers are generated. So that's how all of these three works. Okay, depending on your requirement, you can choose either you want to have the same number or a different number, or you want the next number to be missing or not. It all depends on you. So let's say now I'll ask you, for each department, I want to know the highest salary. So why do we use these window functions? But without the window functions also, we can do the same thing. How? But that is little complicated. Okay, let's see first with using the window functions. Uh, I want to know the highest salary for each department. Okay, so let's take any of this. I will consider that. So we cannot directly apply a filter on this using a where clause or using a having clause. We cannot apply direct filter on this. Let's say where this one equal to 1. It is not possible. Let's see. Okay, window functions can only appear in the select odd order by clauses. It is not allowed in the where clause. So it is not allowed. So we cannot directly use this column. Mm, let me remove the other two as well. Okay, it's up to you whether you want to use row number, rank or dense rank. But whenever there are repetitions, I recommend you to use dense rank so that it will give the proper sequence. Okay, let's say in a class, in a student's class or maybe a college, you are giving the ranks based on the marks. Okay, so the students who are getting the same marks should be given the same rank, and immediate person should be given the rank too. That's how you have to understand it. Okay, now let's see. This will give the sequence for each department. Okay, for each department, I want to know the highest salaried employees. So for that, I need to apply a rank filter on this column where DNS rank equal to 1. How do I do that? I will make this a common table expression with CT as you can have any name for this. It's up to you. So with CT as select star from CTE where now you can directly use this column, the derived column, because this complete data will be residing in this CTE and you can directly refer the column names of that where DNS rank equal to 1. So now for each department, it will give the highest salary. Okay. Or you don't want this number to be here. Just write the select whatever columns you need. Employee ID, name, salary, department, department ID. Okay. So it all depends on you. What do you want to select? Or How do you want to select? Let me also keep that with star so that it would be there for your reference. Okay, rank. These are all highest salaried employees for each department. Okay, now let's say I want to know the second highest salary for each department. If you see here, the department 101, sorry, 1001, it has three employees who belongs to the same salary, who are having the same salary. Okay, all of them are the highest salaried employees. Okay, so now I want to know the second highest for each department. Just write the number 2. All the numbers are already derived. See here with this one, sorry, not this one. With this inner part of the query, all the numbers are there, all the ranks are there. You just have to apply a filter. Okay, so let's say second highest salary for each department. Okay, these are the second highest salaried employees in each department. These questions are definitely asked in the interviews. They'll make you to write the queries uh, to find the highest salary in each department, or the second highest salary, or third highest, or nth highest. We don't know which highest they'll ask you, but definitely they'll ask you this kind of pattern questions. Also, they'll ask you the difference between row number, rank, and dense rank. Now, let's see the meaning of window functions. Where did we write it? Okay, window functions. For each window, we need to calculate results. It might not be always be a sequence. This sequence is applicable only for the first three. Okay, for each window, or window means partition. For each window or the partition, we need to calculate results based on the order. Okay, so that's about the window function. Now you can see, I mean, you can write any, you can find any highest salary or any least salary. If they want you to make you, if they want to find the least highest, just make this in the ascending order. Okay, make that in the ascending order. Let's write it here. Highest salaried employee in each department. Now this is second highest, not second highest. This and this is the same, and this is the second highest salaried employees in each department. Okay, maybe if you want to find the department name as well, join that with the department table. One second, let me copy it. Okay, it's already copied. Okay, let's join this with the department table. You can join it inside or outside, not a problem. Employee E, inner join department D on E dot department ID equal to D dot department ID. Okay, now you'll also get E dot star, which means all the columns from the A, and from the department table, I want to have the department name. I don't know how the name was. The trading tables. It's taking long. Let's write select star from department. Department. Okay, department name. Okay, here also write department. Let's run it. Syntax error where it is with CT as okay, comma is missing. Ambiguous department ID because department ID is available in both the tables. That's why it was showing ambiguous. Let's say employee ID e dot employee name e dot department ID e dot salary. Here also let's provide e dot. Okay, now for each department you are able to find the second highest salaried employees along with the department name. Okay, so we are using the common table expressions. Maybe for the same thing you can also use the subquery. Let me show you how to use subquery. This is our inner query because this is where complete result is available. On top of that, let's run it. On top of that, I need to apply a filter on this column, right? So select star from this inner query where DNS rank equal to 2. Okay, incorrect. We should provide some alias name to the inner query. Okay, so these are all second highest salaried employees. If you don't want star, select the required columns. It is up to you. Okay, so any doubts so far in the row number, rank, and dance rank? Okay, all good. Okay, now let's see lead and lag. These are having the different functionality, unlike row number, rank, or dance rank. Those are used to generate the sequence of numbers, but this lead and lag are used to get previous or the next values within a partition or within the ordering clause. Okay, let's say um, I think I have to create a new table. Let me see if I have any relevant tables. Yes, okay, let's look at this sales table. Select star from. I am referencing it from a different database. Okay, also change that database DE database. Once again, okay, sorry. So let's look at this sales table. We don't have any data here. Okay, let's look at this one. Sales underscore TBL. This is some huge volume of data. Let's look at some simple things to understand first. Employee manager sales records. Let's see this one. DB. Select star from. Okay, I think this is also having a huge volume of data. Let's not. bother about that. Let's create a new table. Let's stop it. Okay. Mhm. Let's create a table. Create table. Within this DE training, I'm going to create uh, called sales tables. With I will have mm, mm, mm. Okay, product product ID as integer. Quarter means let's say I'll make it a year. Also an integer. Let's just say it's year is an integer, and quarter is also an integer, and sales, this is also an integer. Let's run it. The table created. Let's insert some data into that. Insert into sales values. Product ID is 1. Sales year, let's say 2020. Quarter is 1. Every 3 months we consider as a quarter. So let's say we have 1 to 12 months, right? 1 to 12 months. In this, the first 3 months, 1, 2, 3, belongs to quarter 1. Jan, Feb, and March belongs to quarter 1. 4, 5, 6 belongs to quarter 2. You might know that, but still, 7, 8, 9 is quarter 3. Generally, in the business, they consider as quarters 11, 12. This is Q4. So, every year we have 4 quarters. So, I think quarter 1. Let's make it quarter 1. I think it would be better if we provide it as varchar of. I just want to accept two characters Q1, Q2, Q3, and so on. Let's drop this table and recreate it. Drop table sales. I'm going to recreate it with this new column as varchar. Execute this. Yes. Now this is Q1, and let's say the sales is 500 units or 5,000 units. I'll insert a few more rows into this for the same product. I'm just talking about one product here. Quarter. Oh, so we'll change the quarters. Quarter 2, 3, and 4. Let's make some changes to this as well. Somewhere there might be a decrease in the sales, and somewhere there might be an increase in the sales. Okay. So this is for this particular year. Now I'm switching to another year, starting with 3, 5. This is 4, 3. Okay, and this is all 2021. Q2, Q3. Let's insert few more rows. Q4, 2021, quarter 4, let it be. So I'll make another product. Okay, let's make another year, 22, 22. I'm intentionally making this data in a specific pattern. You will understand while we write the functionality. This is Q4, 2, 3. Again, this is 4. Okay, let's start with this 6,000. 7, 5, 8. Okay, so this is for product 1. Let's make something for product 2 as well. I'll just change the code to was changed. Okay, let me change here as well. 3, 3, 5, 4, 5, 3. Make it 5, 6, 4. Okay, let's insert it. Q1. This is for employee 2. Okay, so let's place commas everywhere. So most of the times, lead and lag are used on the date related things or the time related things. Mhm. Okay, so this is the end. Let's run this completely. Okay, 24 rows inserted. Let's do select star from this. Okay, we have the data. So let's see if we have any duplicates here. Okay, so I want to know if there are any duplicates here. So select star, comma, count of star. How do you find the duplicates? Count of star. Whatever you are doing aggregates, other than the aggregates, whatever you are selecting here, that should be there in the group by clause. Group by product ID, failed here. If all of them are same, then only I want to consider that as a duplicate. Why is it quarter one? Okay, let it be quarter one sales. Okay, let's see this. Okay, this is number of rows. Okay, so if this count is greater than 1, then it should be a duplicate. Okay, let's see. Having count of star greater than 1, then it's a duplicate because it is same on all the columns. Okay, these are the duplicates. Let's see. Select star from sales table. What is the year? Product ID equal to 1, where product ID equal to 1 and sales year equal to 2021, and I'll just check for one row first, and quarter 1 equal to Q1 and sales equal to 35. Let's see why we have two rows here. Okay, yes, there are two rows. So I'm, I mean, here we are little deviating from the lead and lag. Let's see. Let's see lead and lag also. First, let's clean up this table. Okay. My intention is to clean up this table. So this is also another important concept to clean up the table. Okay. So let's say I want to have only distinct records in this. I don't want this kind of duplicates. I want to delete them. Okay. So in order to delete them, first we should create another table with the distinct values. Okay. We should create another table with the distinct values. Or one second, let me connect the charger. So first let's clean up the table so that we will also cover one more concept. Clean up this table. So how do I clean up the table, or how do I get duplicates from this table? We have identified the duplicates by using this query. Okay. We have identified by using that query. So now let us see. In order to delete that, we cannot directly delete. If I put this condition, if I write this condition, all these conditions, all the two rows will be deleted. Okay, but I don't want all of them to be deleted. I just want to delete only one of them. Okay, so before deleting, let's see how many we have. Count of star from the sales table. Okay, these are this is how the real-time scenarios looks like. Unknowingly, we will get some duplicate data and we want to delete that. Okay, there are total 24 rows. So how many distinct are there? Let's see. Count of distinct means it will give the unique values. Okay, we are not allowed to use distinct here. Instead of that, let's write distinct star from sales table. We are getting 21. Okay, we are getting 21. Here we have how many? 24, which means three of them should be removed. Three of them are duplicates. So how do we remove duplicates? First, we have to collect this distinct data, dump it to some temporary table, and insert it back to the main table. Okay, first let's see. I'm going to create a new table with this data. I'm creating a temporary table. Okay, first let's discuss what temporary table is. It means it is valid for only a session. Valid only for a session or 8 hours. The table will be there only for a session, or it will be there for a period of 8 hours. Okay, beyond that, the temporary table will not exist because this is created for some temporary purpose. Okay, in order to store some data for temporarily, we are creating this. Later, we don't have any use with that. So let's create it. How to create that temporary table? So let's say select star into select a distinct star into. So the temp table, we have to prefix that with the hash. Temporary tables has to be prefixed with a hash. Then only it will be able to understand that as a temporary table. Select a distinct star into this table from sales table. Okay, let's run it. Okay, 21 rows inserted into this temporary table. Yes. Let's look at that. Select star from this temp sales. While referring also, you have to write that hash. How there will be a question. How do you identify temp table and the permanent table? So temp tables are prefixed with hash. Okay. So now we have 21 rows here. For the original table, it is still having the 24 rows. First, we need to clean that table. Delete from the main table, which is sales. Okay, I'm deleting from the sales table. I will insert back from this table. Okay. Insert into sales Select star from temp sales. Okay. We have temporarily collected distinct rows into this temp sales table, and we have dropped the original data from this table and inserting it back from the temp sales, because temp sales will not be available tomorrow. Once I close this session, the table will not be available. So, okay, now this original table has the 21 rows. It is good. Now it doesn't have any duplicates. Now let's run this query. You should not get any rows now. Okay, nothing. So which means duplicates are avoided now. This is one of the way where if all the rows are same, this is the way to delete them. Okay. So all the rows, I mean all the product sales here, quarter sales, all of these four rows are having the same values as duplicates. So there is no filter criteria to avoid to keep one and delete the other. Okay, that's why I have created a temp table by selecting the distinct rows into that and deleting the main table and inserting back. This is one of the approach. Okay, so with this, you know what a temp table is now. Now let's see the lead and lag function. Also with this, you know how to insert data from one table to another. Okay, we are inserting into the sales table from another table. It might be a temporary table or a permanent table also. So here also provided the columns in the target table should be in the same order as that of the source table. Otherwise, you need to specify the columns in the order in the target and also the same order in the source. Just like how you are doing the insert. Okay, so that's about the duplicates and the temporary table. Coming back, let's look at this sales table and see how to apply lead and lag. First of all, understand what lead or lag is. Lead means the next one. Okay, let's say for the year 2020, I want to know the difference between the quarter 1 and quarter 2. Whether there is an increase in the sales or decrease in the sales, I want to know. How do I get that increase or decrease? We are humans, we know that first row has to be compared with the second row. But in order to make the sequel understand, we have to write some scripting. How we write that scripting? There is no way we can compare the first row with the second row unless and until we bring this row to the first row. We bring this row next to the first row. We have to bring this 4000 next to this value 5000. Then only we can make calculate the difference. Otherwise, it's not possible. So the next quarter value we have to get it here. Next means lead. Previous means lag. So let's say you want to get the previous value 5000 into the second row. We have to use lag. So lead and lag are used to get the next and the previous values within that order by clause. So lead and lag. Okay. Get next value in an order within the partition. If there is a partition, so in that partition it has to get, otherwise if there is no partition within the order we have to get. So this is get the previous value. Lag is previous and lead is next. Let's see that. Okay, so I want to get the next sales value here, next quarter sales. So select star from star comma. I want all the columns along with the next value into here. So lead off. So what value you want to bring it to the next? So the sales value. I want to bring the sales value next to the first row. For every row, the next row has to be brought to the current row. Lead of sales value over. So how do you want to do this order by? Order by on the sales year. Okay, order by sales year and 1 second. Yeah. Okay, lead of sales over. I want to do order by sales year, comma, quarter. I want to do ordering on both of them, year and also quarter. Okay, in the ascending order as next sales. So I'll tell you what happens. It will also take into consideration the product too. Let's run this first. I'll apply a filter on product 1 where product ID equal to 1. Let's first consider only for the first product. We'll see the next product later. Okay. Let us also run this. We'll run this both at the same time so that you will understand what is happening. Let's adjust the windows. Okay. If you see here, year 2020, quarter 1, the current sales is 5,000. So the next quarter, it is Q2. It is 4,000. Yes, 4,000 has come here. Now it is 6,000. It is here. So the next value, every next value is uh, presented here. Okay. So after this last value, there is no next value. That's why it did not give us anything. Okay. So now we will calculate the difference between the previous quarter and the next quarter. Let's see. Okay. I'll make this a common table expression because I cannot directly use this column in the filter. So let's make it with CTE as. Okay. Now select star, comma. Instead of star, let's select the columns product ID, product ID. Sorry, 1 second. Select from CTE, product ID, sales year, quarter, sales, comma. Next sales. Next sales is from this derivation. Next sales. Let's make into a new row. Next sales, comma. Difference of this. I want to find sales minus next sales. Sales minus next sales as difference. Okay, let's run it. Where is the error? Product ID, sales year, quarter, sales, next sales. This has the difference. Okay. So this is the difference. 5,000 minus 4,000, it is 1,000, which means there is a decrease in the sales. So what I want is, I want to mention the decrease as the negative values and increase as the positive. If you see here, this is the other way. From 4,000 to 6,000, it is increasing and it is showing as a negative. So let's make it positive. Sorry. Okay, so next say we have to do it the other way. Next sales minus sales. Next sales. Why is it coming in the uppercase? I did not. Oh my god, keyboard is not working properly. Next sales. Okay, you just have to reverse it. Next sales minus sales from that table. I'm not able to type, some issues with my keyboard. Hmm. While I'm typing comma, it is working like a shift. Okay. Let's keep the previous values at least. It's not working. From CTE, let's run it. You are getting the next sales and next sales. Here we have to write, okay, next sales minus sales as difference from the table. Okay, now it is giving properly. So wherever there is a decrease, it is showing with negative value. Otherwise, it's positive. If it is no change, it is 0. Okay, so it is giving for each year. I mean, quarter-wise differences. Okay, so I'll stop it here. We'll continue in our next session as well for this lead and lag. I'm sharing this notes. Let's save it. It is already existing. Make it 6. Okay, I have shared the file in the chat. Please let me know if you have any questions. Otherwise, you can drop off.